Hello everyone, welcome to this video. And in this video, we're going to discuss triangle congruence postulate that we're using in order to prove that triangles are congruent. Okay, let's start. When we start this one, I want to have some primer starting, which is discussing included side. So an included side is in between two given angles. So let's have some analysis here. Okay, let me have my pointer. So it would be nice to have this one. So given now, if we have now angle A, as you can see, this is now angle A, and this is now angle C. The side that is included is side AC. We're able to see now the logic. So if you have now angle A, which is angle A is from this point to this point, and then we have now angle C, which is from BCA. So what is now the common, or they have now the common side, which is now AC, and that is now our included side. Now, another one is angle B and angle C. As we can see now, the common side is BC. And we have now angle A and angle B. So the common side is AB. Okay. Now, let's have now what we call included angle. Now, an included angle is in between two given sides. So in example, now, let's have now a table again. So let's have now this one. The side is AB and then BC. So what is the angle that is formed by AB and BC? That is now the included angle. Another, we have now AC and BC. So what is formed between the two sides of the triangle is the angle that is included. Now let's have now AB and AC. So the angle that is included is A. Okay. So now let's start now with the first postulate, which is SSS. Remember that there are six corresponding parts of triangle that have measure. So now, if you just need three parts to say that these are congruent. Now, the first postulate is that it is the SSS, or what we call the side postulate. Now, when we say now side, it means that the corresponding sides of the true triangle have equal measure. So if they have the equal measure, so they are congruent. So if three sides are congruent, then the triangles are congruent. Now let's have some analysis. Now we have now BC. Looking now that there are three marks or tick marks. So BC is equal to RQ. We have BA is equal to RP. And we have now AC is equal to PQ. Now, the implication, if they're equal, so they are congruent. So BC is congruent to RQ, BA is congruent to RP, AC is congruent to PQ. Therefore, if the three sides are congruent using now the postulate, we could say that triangle BAC is congruent to triangle RPQ. That is, the reason is by SSS postulate. Okay? Now that is now how we analyze now SSS. Okay, now let's go to the next one. We have now the side angle side postulate, or SAS. So as you can see, this is now our figure. So we have now here the figure. So as you can see, RI and then EI. So we could say that RI is equal to EI because of the tick mark. And remember that the angle should be included, right? However, what I put here is that KI is the same with PI. So as you can see, KI, two tick marks, and then PI with two tick marks. Now, the angle is RIK and then EIT. So you can see they have the equal measure. And look at now the analysis here. The angle is between the two sides, right? So this is now the included angle. So make sure that this is the included angle. So when we say that, SAS is that if two sides of the triangle has congruent measure or equal measure, and the included angle is also has an equal measure, so therefore the triangle would be congruent. So we can say that RI is congruent to EI, segment KI is congruent to TI, and then angle RIK is congruent to EIT. So therefore the triangle RIK is congruent to triangle EIT by SAS. Okay, now let's go with the next postulate. So the next postulate is known to be as the angle side angle. Now, in this manner, there is now an included side. So it tells you that if two angles of the triangle are equal to the has an equal measure, to the corresponding angles of the other triangle, and the included side has an equal measure. Therefore, it could be proven that it is now congruent. So, for example, this one, we could say that angle ACT, which is in the orange, and angle UTC have the same measure. We have as well, when we analyze here, APC is the same with the measure of UCT. And then by reflexive property, the CT have the same measure, right? They have the same measure. So CT is equal to CT. And CT is an included side of the two angles, two pairs of angles. So we could say that angle ACT is congruent to angle UTC. Angle ATC is congruent to angle UCT. And CT is congruent to CT. Therefore, we could say that triangle ACT is congruent to triangle UTC by ASA postulate. And then let's go to the last one, which is the SAA, or what we call the side angle postulate. Now, the side angle postulate is that two angles have the same measure, two pairs of angles have the same measure, and one of the opposite of the angle have the same measure. So as you can see, angle P and angle L, their opposite is side DE. The opposite side is DE, right? So as you can see, when you have that, when you have this one, let's analyze now the equal parts. So we could say that angle L and angle, should be angle P. Okay, this is angle P. And then angle LED is equal to angle PED. DE is equal to DE. And then that would be angle L. That is not correct. Angle L is congruent to angle P. And then angle LED is congruent to angle PED. And then we say by DE is congruent to DE by reflexive property. So we could say the triangle LED and triangle PED is congruent by SAA. Okay? I hope you learned something with triangle congruence. So you can now practice now looking on the work, looking on some details on the internet or in your book regarding the triangle congruence. So once again, the triangle congruence postulates are SSS, SAS, ASA, and SAA. Thank you for watching and have a great day.